Thank you very much for being here. So let's talk about Apache Maven and all the Java versions it supports. The good news is Apache Maven runs fine on JDK 9. This is one of those sentences from last year when Java 9 was released. This year, Apache Maven worked like heaven with JDK 11, and actually also 12 early access, which I just installed this morning on my machine, the latest version. And I'm going to show it to you, because if there are issues, they're probably related to the plugins. So it's a matter of updating those plugins, and you should be fine. So let's start with a demo. So what I'm going to do is I'm going to use a very, very old project. And the project is this, Maven by example. There was a book, I think about 10 years ago, published, and it had a zip file with all kinds of examples. So I'm going to open this one, and we're going to use quite an old application using one of the first Spring and Hibernate combinations. And it's also a Maven module project. So here we have a simple parent, and then there are a couple of small modules. And this is called a weather application. So let's see if we go here. Here. And let's start with using Maven 3.5.4. So that's the latest. And I'm going to use Java 12. So let's see. Maven. Let's start with validate, just to show that it runs. Works fine. And just to prove that I'm really, really using Java 12, here you see it. So let's make it a little bit more difficult. Let's try and do a compilation. Does Maven compile? Right. So right now, we see a failure. And the reason is, this is, like I said, a very, very old project. It used to be built with Java 5. But with Java 12, it is not possible anymore to build this project with 5. So you should at least use 7. So we have two options we can do. We can either say, OK, let's require at least Java 7, or, and that's what I'm going to start with, we're going to use the tool change. So Maven itself will run on Java 12, but the compilation will be done with an older version of Java. And it works like this. So I have here a small snippet of the Maven toolchain plugin. I think I need it all. Plugins, and I'm going to copy it inside here. So here you can see that it is requiring Java 5, and here I'm going to add the tool change plugin. So what tool chain does is there's this XML file. Normally it is located here in your .m2 folder, and here you can specify where all the versions are located on your own system. So based on this, it can pick, based on the version, which JDK home is used to compile this stuff. So let's see. Maven compile. And if you take a good look at it, you can see that the toolchain is picked up and it's using the JDK 7. So right now I have a project which is compatible still with Java 5, and it is built with Maven running on top of Java 12. Actually, I can do it also with Maven 3.0. Maven clean compile. Just to show you that Maven itself is still a very good application. It's clean, it's not using some kind of unsafe methods. So I'm using a very old Maven on top of Java 12. You see it's still white, no colors here, so I really like to switch back to the latest version of Maven. So here I show you that even the oldest projects can simply run on Java 12. Let's go back to the presentation. So the next thing you can do is a module descriptor. I will show you a small example of module descriptor later on. And the first thing you need to do is create this module info file. And you can add it to the root of your source folder. So basically that's always the source main Java folder. You also need to upgrade your Maven compiler plugin to 3.8.0. That's the one supporting Java 11 as well. And step 3, there's no step 3. So this is all you need to do. The plugins are capable to detect which dependencies should be put on the module path and which should be put on the class path. There's no new dependency element. In the beginning, we were thinking of, they suggested that we should do something like that, but that wouldn't make sense, because then you are suddenly responsible for deciding if dependency should belong to the module path or the class path. So let's go back to the period when Java 9 started. So in the beginning, we had Maven, we had Java, and they were living next to each other. Maven was running on Java, and this was fine. And then suddenly, we got Java 9 and 10 and 11. And now there's a small overlaps with things you can do with Java and things that was already supported with Maven. And that's some parts of the specification of the Java platform modular system. These are the goals of the specification. So one is about reliable configuration, and the other part is about strong encapsulation. Especially the reliable configuration is about dependency management, and to ensure that all the dependencies are there during both compile time and runtime. Strong encapsulation is about keeping your code private to other libraries and frameworks. So this is a very, very small example about of such a module info file. So it all starts with the module and its name. And below that, you can specify all the modules you require. And you must specify all the modules you require. So in the beginning, I thought, well, you only have to specify the modules that are real modules and you can refer to, but it's not like that. You really have to specify all the required modules, just like you need to specify all your required dependencies. And with the strong encapsulation, you specify all the packages you want to make visible to other frameworks or libraries. This is a whitelist, and it doesn't support the wildcard like you have with import. So you must be very explicit about all the packages you want to export. So you must be very, very careful if you want to start modularizing, because you can corrupt the whole Maven ecosystem. And I will show you a couple of things later on. But library builders should be aware what they can do when they add module descriptors to their jar files. And application builders, probably most of you are application builders, you should be able to recognize these issues. And if you see them, just go back to the library builder and help them to improve their module descriptors. So from the beginning on, somehow, everybody was complaining and saying that Maven wouldn't run on Java 9. And as I showed you, even one of the first Maven 3 versions just runs fine on that early Java version. Probably the reason for this is that we've been quite critical about the specifications. And we've been able to revise a couple of those. So one of the first is jars on the module path. And the other one is a new flag, which says support all module paths. Then this one is about module names ending with a number. And the hardest one, and this is one of the reasons why Java 9 was once delayed, that's all about the discussion about automatic module names. So let's start with jars on the module path. So when they started with the specification, they said, well, we're only going to refer to directories, because if we're going to specify all the jars, you get a huge line of arguments on the command line. So that was the reason why they started saying, well, just refer to a directory. But if you know how the Maven works, Maven just works by referring to an explicit file. And if we would use the directory where this file was located, there are other files in it as well. So as you can see, for instance, the Java doc and the sources are also files that are located next to the jar file. So how do I know for sure that the right jar is picked up? So they changed that specification, and now we can just add jar files to the module path as well. Like I said in the beginning, I thought that you could only refer to modules you know that are real modules. So you have the choice to not add all those modules. And for that reason, I wanted to have something to say that, okay, so I see there's a module descriptor, and I just want to add everything on the module path, so it will compile. And for that reason, I asked for this option. So they introduced this, but now that I'm aware that the Java platform modular system is working a little bit different, we don't use this anymore in Maven. However, it is still usable, so they still kept it inside the specification. So in short, it's saying, make all your entries on the module path visible for each other. So now, let's start with the hard part. It's about module names. So when I heard about modules, I had this kind of déjà vu. What is a proper module name? It's a little bit like, what's a good group ID? And what's a good artifact ID? And group ID and artifact IDs, those are two separate entries, whereas the module is just one. And this makes things a little bit complicated. So one of the things we saw is that in the beginning they tried to not allow numbers in the module name. And I said, you cannot do that. And the reason for it is we did a survey in the Maven Central, and we had a look at how many artifact IDs ended with a number. And that were close to 30,000 entries. And I divided them into 3 groups. So the first group, I would call them project or product names. So, for instance, the first 3 are Amazon products, and somehow Amazon chooses to end their products with numbers. Then we have a C3PO, a database driver. It would be weird if it should be called C3P. Or DB2, suddenly DP. Especially JSR. There are quite some JSR jars, and by removing the numbers, they would all, in the end, would all be the same. So that doesn't make sense. The next group are versioned libraries, and especially Commons Lang. What they did is with Commons Lang and Commons Lang 2 and 3, they broke backwards compatibility. But that also meant that they introduced a new artifact ID, and they also introduced a new package. And that's very, very good, because now it is possible to have both Commons Lang 2, and Commons Lang 3 on the class path. If they had decided to remove this number, that would not be possible anymore. And then we have the third group, and these are bridges to different versions. And especially the last one, Surefire, which is the testing framework of Maven. It has a couple of bridges, and in this case, it has a bridge to JUnit 3, JUnit 4, JUnit 5, and they should all be possible to be available on the class path. So like I said, the original implementation did not allow to let module names end with a number. So after a long discussion, they decided to revise it and to allow this number. But they said to it, it shouldn't be used as a version, because that's one of the reasons why they didn't want to have this feature. So one of the things I said is that module names must be as unique as the coordinates of the dependencies. And you noticed already in one of the previous slides with the command lang, those are 3 different artifact IDs. So it should be possible to put them all together on the class path or on the module path. But there's also this thing about automatic module names. And if you take a look at the specification, it ends with this line saying, the module name is otherwise derived from the name of the jar file. So suddenly the name of the jar file becomes very, very important to them. And in the beginning they said, well, okay, and if a library builder wants to choose its module name, what should it be? Well, if the library builder is nice, they should pick exactly the same value as the one with the automatic module name. And then we said, no, you cannot be serious, because there was this issue with NPM, and this clearly explained what could happen. So for those who are not aware of this, with NPM, there was no such thing as a namespace. So there was just a library, and in this case it was called Kick. And Kick was 10 lines of JavaScript, but it was very popular. But there was also a company called Kick. And they said to this developer, well, we want to claim that Kick file, or the Kick name. There was a lot of discussion, and this developer decided in the end to say, okay, I'm going to remove it from the NPM repository, and you can have the name Kick. And from that moment on, a lot of NPM builds were broken. And that's just because Kick, without a namespace, it is very hard to distinguish them from each other. So we warned the Jigsaw team about this, and luckily they decided to change this a little bit. So if you take a look at unique artifact IDs, we did have a look in Maven Central in October 2016, and we noticed that over 13,000 rows would result in a collision. So this is a little bit unfair, because there are a couple of artifact IDs which are not jars, they are just POMs. So you can remove them from the list, but still the list is very long. If you take a look at library, let's say those are the 400, with the module path there could be only one on the module path. However, with the class path, you could put them all of those 400 you could put on the class path. And that's what you want. So somehow we said there must be some kind of bridge to say, okay, this is the actual name of this library. And that's when they started with something called the automatic module name attribute in the manifest file. If you take a look at this, so the Jigsaw says we really want to have this automatic module concept because it makes it easier for everybody to adopt this. However, we say, if you do that, if you start using automatic module names, they are not stable enough. So in the end, it will cause collisions. So what we say is, if you are a library builder, please never publish them to Maven Central or any other public repository if you refer to automatic module names. And in this case, I'm especially referring to the file name-based automatic module names. However, application builders, because this is the final product, they can choose to do that. They are in control, so that's fine if they really want to refer to automatic modules. The compiler plugin also warns you for it. So it knows, suddenly it becomes quite important to know if you are working on an application or a library. So an application is something that doesn't export any packages. Makes sense, right? And in this case, the Maven compiler plugin will show you a message that you are referring to automatic modules. However, if you are using a library, and that's detected because you export several packages, you will get this huge blocked warning saying that you shouldn't publish this. And if you're using Maven 3.5 or above, you will see this very clearly in color, of course. So about the automatic module names, like I said, the Jigsaw team said this is very important to be able to support top-down migration for applications. But how about this in the middle? There's a group in the middle that also wants to use libraries and also want to say my library is ready for being modularized. So this is one of the lines in the specification, and one of the most interesting things I see here is it says that the Java platform modular system will also be good for large applications. So large applications. And I said, well, up until now, I know only one large application that supports the Java platform modular system, and that's the JDK itself. And I don't expect that the large applications will be modularized within, let's say, 5 or 10 years. It will take a long, long time, and maybe even never. We'll see. The future will tell. So if you have been to different conferences and have listened to someone of the Jigsaw team, you will always see this application. So there is this My App, and it has a mylib, and it is using Jackson Core, Jackson Databyte, and Jackson annotations. And these are all on top of Java base. And we say, well, this is not really a real-world example, because that would look something like this. So we have my applications. It has direct dependencies. They have transitive dependencies, and this can be quite a long list. And on the bottom, you have these Jackson libraries. And I can show you that it is quite easy to make a mistake if you are not aware about how to use this specification. So let's assume we have this library. It's called currency 1.0. It's a jar. It's just a classic jar, no module descriptor. The next day, somebody wants to create a buy service, and it says, oh, this is a very nice currency library. I want to use it. And he says, okay, I'm also want to use this module descriptor to be Java 11 ready. So so he's adding this module descriptor. Then the currency library says, okay, we're going to create version 2.0. We are also going to add a module descriptor with the name org.moneylibs.currency. If there's a buy service, there's of course also a sell service. So here's the example of the sell service, having a module descriptor and also using the currency library. And in the end, we have an application, animal market, and it is using both these services, so both the buy service and the sell service. If you take a look at how the Pom file would look like, it would be something like this, with of course, the model version always 4.0.0, the group ID, artifact ID, and the version, and a couple of dependencies. And the dependencies would look like this. If we change this into a graph, it would be a little bit like this. So you see on the left side your jar requiring 2 modules, and those 2 modules both use currency, and you can see that the buy service is using currency 1.0, sell service is using 2.0. So Maven detects this and it chooses to select the first one. So there's only one currency jar on the class path, or in this case on a module path. This won't compile. And the reason is there's no module anymore with the name o.ms currency, because the currency 1.0 has an automatic module name. It is just currency. So this is kind of weird. So if I was only using by service, no problem. If I was using self-service, no problem. If I'm using both, then I have an issue, and there's nothing I can do about it. We can also switch the by and the self-service. And then the graph would look a little bit like this. So now we have the self-service on top, and especially the currency 2.0 on top. Maven will again select the first one, being the currency 2.0 in this case, with the name o.m.currency. And now, again, it won't compile. Because there's this requires currency doesn't exist anymore, even though you could say, okay, but if this currency 2.0.jar, the specification could say, well, I can translate it to an automatic module name. But that's not what they decided to do. They say a jar can only have exactly one module name, in this case, o.m.currency. So what should we have done? We should have used this automatic module name attribute, and we can add it to the manifest file. And so what we should have done is, during step 2, the by service, he should have said, okay, I'm going to add this manifest file, so I can say to my users, this is going to be the module name I'm going to use in the future. And from that moment on, it will work. However, there's also this point of no return. And it is saying that once you start referring to something with a module name, and a previous version doesn't have a module name, then you have an issue. And if you see it like this in a graph, the self-service, it was referring to o.m.currency, and because the 1.0 doesn't have that module name, it can never fall back to 1.0. So if there is a bug, for instance, in this 2.0 jar, well, I'm not sure what you are going to do. So my strong advices are, your project must be Java 9 ready. So that means there shouldn't be any split packages. Split packages are jars where classes in the same package exist. This is also one of the reasons why Maven itself, it is quite hard to make it modularized. It has its own module system, of course, because we also call it the Maven multi-module project. But it is not the same as the Java modules. And it is not allowed anymore to have classes in the root of your folder. For libraries that depend on at least one file name-based automatic module, just start using this automatic module name and specify it in the manifest file. That's the nice way to start helping the Java ecosystem to become modularized. And pick your module name with care. And in the beginning, they said just use the same value as the automatic module name, but right now they are saying no. Let's use the shared package. It should be as unique. It's not allowed to have split packages, so this should be as unique for that case. Of course, mistakes will happen, and we already had the first issue in Maven Central. So one of the first versions of ASM 6.0, there was a split package issue. So these jars, all these three, have exactly the same classes inside of it. And they have different names. So it was not possible to refer to both these jars. Luckily, they decided to drop the all and the debug all. So now there's only one ASM jar file, and that solves the solution. So tips for using Java 9 with Maven, or 10 or 11. Don't change your folder structure. If you go to conference, you quite often see that they use just source and then directly put inside of it their package structure. But they do that because they don't want to refer to a specific tool or framework. So if you take a look at how Java itself is built, they have their own structure. Maven has, of course, its own default structure. Please keep it like this. And then, how about deciding if you want to use the module path or the class path? You don't have to change anything to the dependencies. The only thing you need to do is you need to add this module descriptor. And there's this library, it's called Plexus Java, and this helps plugins to decide where all the jar files or directories belong to. So you should understand a little bit about this library. So it is a Maven independent library for general Java features. It has a location manager. This one is used for detecting which jars belong to the module path and which belong to the class path. And the other one is about versions. So you can verify if one version is higher or lower than the other. And this library is already used by a lot of Maven plugins. Like I said, it is Maven independent, so if you want to use it, even tools like Gradle could choose to use this library if they really want to. And also, I would like to see that Eclipse and IntelliJ and all those other IDEs will use this library. So they all have the same logic. So if you take a look at the location manager, the only thing what you do is, what it is looking for is, if there is a module descriptor, I will go through all the files, the jar files you have, and first I'm going to analyze them to see what the name of it is. And after that, it is going to build up the whole graph, and then it knows, well, okay, I saw that this one was required, so I will put that on the module path, and all the rest will go to the class path. Most of the time, you can switch on the debug logging on a plugin, and it will show you where all these files go to. And one other important thing, learn the Java platform module system specifications. So we had, every now and then, we get issues that some plugins are not working. But in fact, it is all about the details in the specification. So you should really try to learn it. Somehow, it is not possible right now to become Java Platform Modular System certified. As far as I know, the latest available certification you can have is still Java 8, which is kind of a shame, I think. Then, at quite some conferences, they are also talking about JLink. And with JLink, it is possible to create a new JDK or to wrap your application and bundle it with a JDK. So what you do is you create a new runtime image. This is actually the advanced solution of a fat executable jar. However, I think it is overrated. Right now, I'm pretty sure that almost none of the applications can use it because there's one important detail to know, and that it works only with explicit modules. So if you have at least one automatic module in a reference in your module descriptor, you cannot use JLink. So it will take quite some while before JLink is really suitable to create your applications with a customized runtime image. Then there's also this source and target. I see this quite often, especially on Stack Overflow, and I say, please, don't use the source and target 1.9, because if you see this, please use the release flag. And I will show you why. So with source, you specify the language or the syntax. So in this case, I want to have this project be compatible with Java 7, which means I cannot use features which were introduced in Java 8. So the first one is a method reference, and the second one is a lambda. So let's see. If we take a look at the first one, it says, well, I can fix it, but then I have to change the source level to 1.8. We still want to make this code compatible with Java 7. So we're not going to use this one. Let's remove it. So we have the second one with the lambda, and now there's certainly a second option which says convert this into an anonymous class creation. So let's do that. So now the code looks like this. So no method reference, no lambda, this should work, right? Let's go to the demo. Hello world. Commands. Latest version. And let's see if it can be built with Java 8. Clean compile. Works fine. Let's try it with Java 7. Because in the end, it needs to be compatible with Java 7, of course. So this is interesting. What you see here is that it doesn't recognize the consumer class. So here I'm using the consumer class, which was introduced in Java 8. So even though it looks like this code is Java 7 compatible, it is not, because it is using classes from Java 8. And the release flag will protect you with it. However, Maven already has a solution for quite a while for this, and it is called Animal Sniffer. Animal Sniffer, it looks like this. Let's open it. So you add this plugin, and you can also add a signature to it. And from this moment on, it will verify if all the classes, all the methods, etc., are available in Java 7 or not. So let's try to run it again with Java 8. And now the animal sniffer is also activated. So if I run Maven package, not just compile, because the animal sniffer is bound to a phase after the compile phase. Let's do also the... And what I am hoping to see is that the build will fail. And it does. So it is already right now possible to verify if your code is really, really compatible with the version on your production system. So even though you are on Java 12 already, it is possible to write code and verify that it's still compatible with an older version. So this is exactly the reason why they introduced this release flag. So let's do that. I will change this. Oh. Something like this. And it doesn't matter that source and target are there already, because Maven compiler plugin knows that if you have specified a release, it will pick that up and it will ignore the source and target values. So if I now switch to, let's go to Java 12 again, and now I have activated this release flag, and now I'm going to do Maven clean compile. Right. So this is exactly what you want to see. So the code is failing because it is not compatible with the version you have specified. So from now on, please try to use this, this flag. Like I said, if you are using Java 8 or before, you can use the animal sniffer as well. In general, if there are issues One of the most common places you can go to is, of course, Stack Overflow. I am there quite active, and I'm pretty sure there are a lot of other people understanding the specifications about the Java platform modular system and all other stuff related to that can help you. If you think there's a bug, of course, you can always go to the Apache Maven mailing list. And there's also, of course, Jira, where you can say, well, I found a bug or an improvement. But please be sure that it is really a bug. Sometimes it is fine to just go first to the mailing list, ask if this is really a bug, and then we can work on it together. There are, of course, always some frequently asked questions at conferences. And one of them is, can every project become modularized? And my personal answer is no. It can be very hard, especially for applications that already exist. It is probably not worth it to make it modularized. So Java 9 is really a game changer. There are suddenly new rules, like I said about the split package issue. Those things weren't there before, so why should you bother about it? All the projects probably cannot follow these rules, so that would imply that you have a lot of refactoring to do, and that's not always possible. In case of Maven, we have this split package issue, and we actually call it evolution, because we know that some classes actually belong to another jar, so we started moving jars from over to other places. But with this new specification, we cannot revert it back. So we need some kind of strategy to fix this for Maven. But right now, there's no need for it. Because the class path will stay there, and it will stay there forever. Somehow, a lot of people also think that the class path will change. It's not. So, like I already showed you with Java 12 and the old weather application, you can simply run it right now. The class path will really stay. Mark Reinhold also retweets this every time. And the other question is about, can Maven generate this module descriptor? Because as you might have seen, there's some overlap between the dependencies in a Pom file and the required modules in your module descriptor. And in this case, the answer is exactly the same as the one of the previous slide, and it's no. And one of the most important reasons is they have different purposes. So in the Pom file, you specify the dependencies, and they are used to download these jar files and to make them available for the plugins. Whereas in the module descriptor, it's more like a check: are all these jars available? And not all modules are dependencies. So if you want to use Java, the Java logging module or the JDK compiler plugin, you cannot translate it to something like a dependency. Then there are much more elements in the module descriptor. So how would you specify the module name? How would you specify that the module is open? How would you like to specify which packages are exported? And also, how about the users and provide mechanism to specify the services? There's just no option to detect it by Maven. This is really manual stuff you need to do yourself. Also, the current Pom file has no option to add new elements. The Pom file is not only used by Maven. There are a lot of other tools that are also reading this Pom file, and we don't know what will happen if we add suddenly new elements to it, even if we change the XSD location. So for now, we will stay on Pom 4.0.0 and won't add any new elements. And there's another thing somebody reminded me, and that's about Pom hygiene. And who knows this goal, dependency analyze? Ooh. Okay, so what this goal does is it scans through your code and through your dependencies, and it's taking a look at if dependencies are really used. So there are three categories. The first one are the used and declared. Perfect. The next one are used and undeclared. So these are dependencies you get via a transitive dependency, but you should actually make them explicitly. And the other one are unused and declared. So maybe you had some code in the past that was using this library, but it's never used anymore. So if we were going to use this and generate the module descriptor, you will get much more modules in your module descriptor than you really need. And there's an issue with it because you cannot remove modules. You cannot exclude them. With dependencies, you can say, well, I want to exclude this and this and this. That's not possible with module descriptor. Once it is there, it must be available on the module path. And I can show you this a little bit. So if we go back to our example of the weather. Here, I'm going to call the dependency goal of the dependency analyze goal. So here you see the result of one of the modules of this project. And what you can see is that it's using Java's persist, the persistence API, but it also has some unused declared dependencies, all kinds of hibernate jars. So this is a Pom file which should be cleaned up. What I can do is, let's say I'm going to add a module descriptor to this project. So here, model, source, main, Java. Let's create a new text file. Module info.java. Yes, I'm sure. Edit it. And here I have a small segment. So it has now a module name. It has requires hibernate annotations, persistent API, and it's going to export one of its packages. I'm not going to use this one anymore. So let's go to this one. Maven, clean, compile. So what do we have right now? Oh. So it is complaining. It is still, of course, it is still a Java 7 project. So I should switch to Java 9. So I want here, it's not going to be compatible with Java 5 anymore. I'm going to use release. Let's go for 11. Release. And let's run it again. Okay, so now it's still picking up that's a shame. Let's remove this. I'm not going to use that anymore. Right. Did I save it? I thought so. Okay. Like I said, this is a very old project. So this one was built about 10 years ago, and this one is using the Maven compiler plugin 3.1. And like I said in the beginning, you need to upgrade that to at least 3.8.0, because then it can recognize this new option. Okay, interesting. So what you see here right now is that it is really trying to compile, but it is detecting all kinds of split package issues on both the Hibernate jars. But as I showed you before, it is actually not even using Hibernate. So what we better can do is simply remove these requirements. It is only using the persistence API. There it is. So what you see right now is that inside the target directory, you suddenly will see the module info class file compiled. So this is a good start. Just a simple module. It doesn't have really any dependencies, but you can add a module descriptor to it. And you can go with it to the next module, and to see if it is possible to create it. But like I said, very old applications, it can be quite hard to do that. So let's see. So like I said, POM hygiene is very, very important. So back about generating a module descriptor, because JDEPs can do that, right? There's this option in JDEPs, which is a tool introduced in Java 8, which can help you for analyzing if you are using internal APIs or not. Yes, it can, but it creates a rough model, and it is intended to help you write your own descriptor. So it's generating probably a little bit too much, and after that it is your decision to remove some parts of this generated multi-descriptor. And it is also based on the binary classes. It is not based on the sources, which means that if you want to use JDEPs to create a multi-descriptor, you need to first compile the code, then create this multi-descriptor, compile it again, including this multi-descriptor. Way too complicated. Of course, there are open source projects who will try to solve this issue, and there is one, it is called Moditect. And it started quite simple, but what you see right now is that actually all the information you put in the multi-descriptor is now just moving to the plugin configuration. So I'm not really sure if this is the right solution. I don't prefer to use this, just stay to the original multi-descriptor. So with this, I can say that we can say that Apache Maven really supports all Java. I showed you that you can run Maven itself on the latest version, 12 early access, and even compile projects with Java 5. And with this, I'm almost done. There's one more slide before we can maybe go to some questions. And that's this. It's called Up for Grabs, and it has to do with the Maven project. Maybe you've seen it that this week there was a report from SNCC, and they showed that right now Maven is used by 60% as the main development build tool. But it all depends on how you ask the questions. So it could be between 60 and 80%. If you take a look at the whole project, it's not just Maven itself. There are also, of course, plugins. Half of these, about 100 plugins, are the plugins, and there is much, much more. However, this project is maintained by only 5 to 10 active committers, and there's no company behind Maven. So this means that everybody of us is earning their money with their daily job, and in the evenings or in the weekends, we try to maintain Maven itself. And this is a serious situation, especially if you take a look at the new pace with Java. We have quite some troubles to keep up with that pace. So we are really looking for new committers. So let's restore the balance. If you are interested to help our project, you can go to this URL. And this URL, it contains some of the probably simple to solve issues. And that should help you start understanding how Maven works. Most of the time, these issues are not even related to Maven core itself. These are just simple Java puzzles. At JCreate, I was this summer and we did a hackathon. And we were able to solve this, a couple of these issues like this. We also have this link. If you want to become a committer, this link should give you the right instructions to help you how you can deliver quality patches. And with this, I see still some people making pictures. Okay. With this, I want to thank everybody. Thank you. So,
Robert, thank you, Robert. I guess we have like 3 minutes for one question at least.
Okay.
Sure.
Hi, Robert. Thanks for your talk. You were primarily targeting Maven users. Do you have any recommendation for Maven plugin developers, or maybe the Maven core team as such, when you catch up with new Java versions? Isn't there like a chicken and egg problem if you go to the next Java version?
It is, yes. So the problem we have is some of the plugins are depending on ASM. ASM is released right after the new release of Java. So there's this line of libraries which needs to be released first before we can help. Especially with Java 9, we added some features to the Maven 3.6.0 plugin to be able to experiment with these new features. So that's how we try to do that. So there is some experimental stage sometimes for plugins, but in general, it should work.